every chip counts. So what does it exactly mean? I know the second title sounds a tad bit childish, but unfortunately I'm going to draw a bit of a darker picture. So you probably all have read this quote once in your life, either on a sticker, on a techie blog post, on some Web3 marketing materials, or on a car. Depends on where you live. If you really go in a rabbit hole on this quote, it's sad because it's actually true. And on the other hand, there's lots of people that are arguing against it because they say a cloud is not just a computer, it's very secure, it has all these standards, and it's not really comparable. But at the end of the day, trust is our only option. In this system, we have no control over the security provided by our feudal lords. We don't know what sort of security methods they're using or how they're configured. Whether or not you like Bruce, up to yourself, and also I don't have any hard opinion on him. But I think this quote is really, really embodying the problem that we have, and that you've heard about many times before. Also 2019, if you've been here. So I really like the feudalistic approach here, because at the end of the day, it really is a feudalistic system. We just have a couple of houses. They make the rules. They're very powerful. And these lords of the cloud, at the end of the day, are telling us what to do, right? So cloud computing is really monopolized. The latest numbers I checked, it's 67% for the top 3 companies. If you get all the top 6 companies, it's 75%. So 3/4 are in the hands of a few companies, depending also geographically speaking what you look at. Germany, we have all of the top 4 with data centers, even Alibaba. So clouds own your data and also enable mass surveillance. So this is not news to anyone, but people tend to forget, because if you need to get something done, then you need to get it done. And you don't have time to deploy your own server, your own bare metal machine. Think about access control. You just create logins and roll with the flow, right? Supply chain risks. So clouds also, I'm saying clouds here generally speaking. So if I say clouds, I also mean data centers or resellers or sub-processors. So everything that is like part of this huge mechanism or complex system, I include everything when I say clouds, not just a single company. So they have a supply chain risks, because if you look at like the end-to-end value creation of digital products and also of most everyday life things, at the end of the day, you have a payment involved, you have a logistics involved, you have some sort of digital aspect. And if you look behind the curtains of the cloud providers, they have huge dependencies, codependencies of other sub-processors, because it's highly optimized for revenue generation, right? So at the end of the day, they pose a risk, and sometimes there's a blip on the radar and we realize it if something goes down, or suddenly you lose access to your Azure AD, or suddenly GCP, you log in and you see some commands done by some random admin and you don't know why. So yeah. Clouds are also not censorship resistant. Thinking back to Signal 2018, when domain fronting was prohibited by Google, probably after further discussions with different entities that were not really approving secure messaging. And when I say hard to localize, I mean they're really hard to grab and say, hey, you need to actually implement these laws here in this jurisdiction. Because yes, they might be they might be physically local and centralized, but at the end of the day, they're all huge conglomerates that can dodge these bullets very easily. So, cloud providers are geopolitical actors at the end of the day. And when I say that, I'm not trying to sound like a conspiracy theorist saying this in a way that we should fight them to the death, but it's just a matter of fact. This means they can shape the power balances meaning they can influence, for example, only through pricing within a market, looking at a macroeconomic scale, for example, or microeconomically, they can really diminish players from marketplace. They can undercut prices very easily. So it's really a power balance they have, and they can really influence this heavily, meaning they can also influence conductive statecraft. Lots of data centers are also rented by nation states, meaning at the end of the day, even if it's just operated by a certain cloud provider, access to the data, yes, questionable. And then at the end of the day, I mean, we can go further and further down this line, and it just becomes a bit more crazy. But let's stop right here. They can also influence the trajectories of nation states, meaning if you cannot access your tax data because it's on a certain cloud, then you don't get any money. So just a random example. And another random example, staying not that abstract, but really concrete. I know it's not a cloud example, it's more a centralization example of CrowdStrike that recently happened. And it was actually just a very small bug, and it affected 8.5 million devices. I mean, that's the official numbers that we know. And these are the more or less officially approved numbers that the outage cost. Of course, these estimations always vary. It's very hard to estimate. But at the end of the day, we don't really want to just look at the numbers, right? Because if you just care about the numbers, then it's probably still the most efficient way to run with CrowdStrike or sort of these kind of suppliers. The crazy part is that this file that caused the outage really was updated multiple times a day. This was just a misconfiguration file. And I mean, if this can happen multiple times a day, then if you would do this for, I don't know, 1 week, probably economic stability would be gone pretty quickly. Now, becoming even more practical, going deeper down on the other people's computers, they're even accessed by others. So, and who knows who is accessing the other computer. So this is an email list. Searching through the Outlook app, you can find emails from Google Cloud updating its sub-processor list. And on the right-hand side, there would be a video scrolling down the list of like hundreds of entries of all these sub-processors that are allowed to access your data on the Google Cloud for technical support reasons. But as we all know, if you want to do technical support, you need some sort of access, right? Otherwise, what can you do? You can just tell them to wait, hope their problem disappears. So at the end of the day, it's a huge list of companies, third-party companies that have access to your GCP instance and whatever is entailing this access as well. On this slide, I'm just like summarizing everything a little bit. So there's a huge risk of economic turmoil. Of course, this further down the line can lead to nation states breaking down if certain data centers would not work anymore or decide to work against them. We really have a loss of resilience. Also nothing new. This is why we are all here. Not all of them, all of us, but many of us are like intrinsically and like deep down motivated by this aspect of it. There's a risk for national security. I know this is like a weird thing to say from a privacy activist standpoint, because you usually hear it from the other side of the spectrum. But at the end of the day, that's what it is. We also have a loss of data ownership. So not just privacy, but also the ownership of the data, meaning that IP rights can be a problem, or personal data collected from your customers, etc., etc. I think most of you are aware of this risk. But now let's scope out of the technical details. I just want to question a bit why we are at this point that we are, because that's really something that is a lot on my mind. Have you ever heard about the N-shitification? I'm sorry for using a swear word, but that's how Cory Doctorow minted the term. It means that like every online platform, for example, TikTok or Facebook, just two examples from social media, start with a focus on usability. So like maximizing users' customer rent, but then going next to the business side of things. So optimizing for business revenue, selling ads, for example, then going down to optimizing shareholder value. So that's the third stage. And then the fourth stage is just death of the platform. If you go to many of these platforms, they're full of ads. They're unusable. You need to fill out 700 forms and captchas and whatnot because they've just been enshittified to the death. And also the second interesting aspect that I'd like to highlight is the iron law of oligarchy. So it's like in sociological theory that all complex systems eventually develop oligarchic structures. I'm not saying many crypto systems have this problem, but some of them certainly do. And this also leads to lots of emotional problems, let's put it this way. Although, in theory, fully decentralized systems are less prone to this enshittification, or should be. But then you need to have a working governance system. You need to have a good community, which has been mentioned throughout the panel before, which really highlighted this well. If you do community well, you run into less risk of enshittification because the user stays involved. So it's not just being optimized for businesses or other things. But less prone doesn't mean you're immune. So be careful with that. Also because at the end of the day, it's humans using these systems as well, right? So what do we need? So be careful now. The green stuff might be a bit chilly because I'm referring to accuracy sometimes, but I'm declaring it very clearly, so you don't need to hold your ears. We need a global scale cloud network founded on open source principles. But open source is also enshittified, right? Open washing, greenwashing, everything that can be washed will be washed. So that's another problem. And open does not necessarily mean verifiable. So just if you open source like the non-crucial parts of your protocol, but like the proof generation and verification is not public. I mean, I don't care about your front end. So this is really something that also becomes clear when you look at cryptographic systems. At the end of the day, the implementation of the core protocol needs to be published. Otherwise, it's not really worth it. And now I'd like to quote the latest Edward Snowden. In words from history, let us speak no more of faith in man, but bind him down from mischief by the chains of cryptography. This is, for our American friends, a play on the quote by Thomas Jefferson from 1798, where he refers to Constitution. So this is like the cypherpunk value or idea of what we do, right? And I think this should be a bit more present to all of us in this community during the hunt for VCs or community members. So now our approach, and also an approach for the world, could be to use mobile devices, right? You have less operational expenses. I know this has been a bit of a hard twist now, but one of the approaches to build data centers could be to use mobile devices because they're much more heterogeneous and also decentralized, and also less expensive than server machines. Because in the beginning I mentioned it's really hard for anyone to just bootstrap their own network, right? And what most people don't realize is that they actually have superior performance per watt, but also comparing similar processors, for example, they even have superior processing speed with TPUs, very power efficient CPUs, and also TPMs, Trusted Platform Modules, or HSMs, or however you want to call them, specifically on mobile phones, very secure chips as well. This is, of course, due to the fact of ARM-based hardware. I know there are servers and data centers with ARM, but most of them are still vintage. And one of the cheat codes we can use is upcycling of devices. So very cheap devices that are partially broken. We can also support multiple of the ecosystems. And at the end of the day, everyone has a phone or an old phone. So you can use, for example, 5G uplinks and residential IPs. So one of the examples here is Acurist, actually, because we can build a global network of phones. As you can see, these are all like real people that have phones at home, providing their processing power of the phones to the network for people to deploy deployments to the network. One example is to create AI agents or verifiable and confidential federated learning, or data crawling. So it depends on at which point in time you are in this whole big data loop. But you could use different processors, either they're public or private or dedicated. And of course, this is also applicable to other projects. And then use them in a decentralized way, also with their ingress and egress traffic to fetch the data from different data points. But at the end, it's very generic because we can also run all sorts of code, meaning that we can do, for example, a WASM compile and then run AI agent for hours, days, recurring, that does a job and then returns the data to wherever you want. So that's just one example on how you can use a resilient architecture. Another interesting thing is to bootstrap your own data center on the edge. So fog computing is a word that I heard yesterday. Shout out to Epsilon. They will also talk about unstoppable compute tomorrow. But if you want to build like a data center of your own, for example, in a country that doesn't have one or doesn't have a cloud provider due to any reason, you can just take a couple of phones, distribute them, and then even make peer-to-peer deals. You don't even need to use the payment on-chain, but you can just use the infrastructure to orchestrate and work with that. Here is just a short blip of the architecture that we use, but it's also generic in a way that I just want to highlight why we separate the permissionless consensus layer from the execution layer. It's because we want to have a couple of things publicly verifiable. One of the things is the attestations of the devices. So we want to make sure it's authentic. And also we can do a bootstrapping of the trusted execution environment, which you can see on top in the middle. And that enables us to really make confidential and verifiable compute a reality. One or two interesting side notes is that in peer-to-peer systems, to incentivize honest behavior is that we have a reputation score, and it also has the flexibility to use public or private processors. Yeah, I'm gonna end on this note, and next time you use a cloud, just make sure you think of the first thing that we said about the other's computer and another, other, and other. But that was it. Thank you very much.